Hello and welcome to Unit 4 review. I'm just going to check my settings real quick. Hopefully everyone can hear me okay. That seems to be working. Okay, today we're going to be talking about intervals, and generally people don't have a lot of trouble with this unit. So I plan on moving through this fairly quickly. As indicated in several places in the course, the exam is simply intervals and inversions. So if you can figure out how to determine an interval and then figure out what the inversion would be, you'll be set. So let's start. I'm going to pull up just a blank music sheet, and I'm just going to make some intervals, and let's see how we get with that. Okay, so hopefully everyone can see this well. And I'm just going to add a treble clef. Oops, I had two of them up. There we go. Let's fill up the screen. In fact, maybe I'll make it even a little bigger. So I'm going to add a treble clef. All right, now I talk about this in the first lesson, but when we're determining intervals, we first start with the generic interval. And then after we have a generic interval, we move on to talk about the specific intervals. Now, the generic interval just looks at the letters, the musical letters, the distance between the musical letters present. And the specific interval will look at the number of semitones present. So, for instance, between A and B, generically speaking, we could say that was a second. And the way I found that was to count. And we start with the note head, A, B. So two letters, A, B. That's a second. If I went up here, it would be A, B, C. Another option is you can count lines and spaces. So if I counted lines and spaces between these two notes, space 1, then line 2, space 3, line 4, space 5, line 6. And it does not matter how crazy the accidentals are, no matter what I do to these pitches, it's still some sort of sixth. Generically speaking, it's a sixth. Okay, let's get rid of some of the craziness. Okay. So that is generic intervals. And if you are having trouble with the generic intervals between the bass clef and the treble clef, and it's really the same thing, except you're counting up the staff. So if you remember, middle C is right there, and middle C in bass clef is right there. So this middle C in bass clef and this middle C in treble clef, imagine they were squished together and on top of each other because they're the exact same note. So if I count up, starting with G, G is 1, and then 2 for A, 3 for B, 4 for C. So that's fourth right now on the bass clef. And then I skip up to here. I've already counted the C down here, so I don't have to count it again. So 4, 5 for D, the space, 6 for E, 7 for F, 8 for G, 9 for A, 10 for B. So this would be a compound interval. This would be a tenth. Okay, compound intervals are really not hard. You just have to count up from the bottom. And you have to remember that middle C in bass clef is the exact same pitch, this green one, as middle C in treble clef, and just count straight up. Okay, so we've handled generic intervals. We've looked at compound intervals, let's look at interval inversions. So, and again, we're still talking generically. We're still just looking essentially at lines and spaces. So here we have what type of generic interval? Well, we have a C, that's 1, and then 2, 3, 4, 5, 6, 7. So between C and B is 7. And if it helps, you can look at it this way. 1, 2, 3, 4, 5, 6, 7. See, between C and B, 1, 2, 3, 4, 5, 6, 7. Essentially, we're just counting the letters. Okay, so let's look at inversion. Now, when you invert an interval, you either take the bottom note and put it above the top note, or the top note and put it below the bottom note. So the first instance is let's put the top note above, or the bottom note above the top note. So what does that make? Let's put that over there. Now we have a second. So we went from a seventh to a second, because we just took the C, this middle C, and we put it up an octave. The other option I mentioned is to take the top note and put it below the bottom note. So let's just grab this guy and put him, let's just put another one here so it's easier to see. Put it below. There we go. So I took the top note and took it down an octave. And again, we still have, generically speaking, a second. So it doesn't matter if we take the top note down because we have a B below a C, or the bottom note up. Here we have a B below a C. It's the same. It's a second. It's just which octave it's in. So switching the order of the notes up and down is inverting the interval. So let's try another one. Let's look at F and A. Now here we have a third, right? F, G, A. That's a third. If I invert this, I'm going to take the bottom note. I'm going to take the bottom note. Oh, it seems to want me to take the top note. I'm going to take the bottom note and put it up an octave. So now we have, generically, A, 1, 2, 3, 4, 5, 6. So if I count up A, B, C, D, E, F, 6. Now if I had switched it, let's put that back. If I had switched that, I could take the A and put it below. Oh, that's right. Put the A below, and I still have a sixth. A, B, C, D, E, F. So when you invert an interval, you're just switching the order, the vertical order. So for instance, here's a C and a D, and then here's a C and a D. Make sense? Great. And now what you'll notice is when you invert intervals, and this is important because when you're inverting intervals on the exam, and you essentially have to know which way things are inverting. And essentially, generically speaking, and specifically speaking, it's always going to be a very predictable interval. So for instance, if I invert an A and a B, this is a second. If I invert a second, I always get a seventh. So seconds always invert to sevenths. So that equals 9. And if I invert a third, thirds always invert to sixes. So that's a 9. Fourths always invert to fifths. That's a 9. So seconds to sevenths. Let me just put that original one back up. Seconds to sevenths, thirds to sixths, fourths to fifths. So that's kind of the generic speaking. If I give you a second, the inversion will be some sort of seventh. If I give you a third, the inversion is going to be a sixth. If I give you a fourth, it's going to be a fifth. If I give you a fifth, it's going to be a fourth. If I give you a sixth, it's going to be a third. If I give you a second, it's going to be a seventh. It's going to be it's going to add up to 9. So 2 and 7, 3 and 6, 4 and 5. So this is specific or generic intervals, just looking at the letters. So let me clear off some of this craziness, and let's just review some of the basic intervals. And of course, we go through each one of these, what is called a pairing, second, seventh, third, sixth, fourth, fifths. We go through each, in octave unison. We go through, so 8 and 1, it's also a 9. We go through each one of these in their own lessons, so you can also review those. But let's start with the first one, which I suppose would be a unison. Let's look at D and D. There, this would be a unison. They're both the same note. So I'm going to put 1D up an octave. So I've inverted it from a unison. There's nothing there. It's a 0, right? 0, or I guess you'd say it's a 1 because you always count the letter you start with. So 1, this is a 1, and plus 8 would be 9. So I've inverted it. I've made a ninth, and if I count up 1, 2, 3, 4, 5, 6, 7, 8. So that's a unison. Now an octave, which is we've got a perfect unison and a perfect octave. An octave will have a certain number of semitones between it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, just let me pause for 1 second and pull up another graphic. Think about what the best way to demonstrate this is. I'm just worried that you won't be able to see it on this, but yeah, maybe that is the best way to do it. Let me pull that back up. So we've got generics down. Let's move on to specifics. And as I said, we were kind of looking at the octave, but I think maybe even more important than the octave immediately is just how to count semitones. So we've already seen that when you count generic intervals, you start with the bottom note, and that is essentially 1. So between D and D, you'd be 1, E would be 2, F would be 3, G would be 4, A would be 5, B would be 6, C would be 7th, D would be 8th. It's a little different when you're actually counting semitones. This we've just essentially counted letters, right? D, E, F, G, A, B, C, D. Here we're going to actually count semitones, and we're not going to count individual notes. We're going to count kind of what I like to think of as motions. So let's look at the keyboard above, and can you see that? Let me see how it looks there. Oh, let me scroll up. Damn it. Oh, pardon me. Let's go from this D all the way up to that D, and I guess that's kind of visual. So what I mean by movements is the semitone distance between 2 keys. So I would say this would be 1. So the motion, 1 D to D sharp, 1 semitone distance, 2 semitone distance, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there's 12 semitones between D and D. Let's do another one. If I go back to my perfect unison, there's D and D. How many semitones? There's 0 semitones, right? There's nothing. But if I do D and D sharp, this key and that key, there's 1 motion, right? 1. Okay, and if I do D and E, there's 1, 2. How about D and F sharp? See if you can figure that out on a keyboard or whatnot. So I go start to D, and I'm going to go here, and I'm counting semitone motions. So 1, 2, 3, 4. There's 4 semitones. How about that? And it's okay to have a keyboard in front of you. You can use the pop-up piano. I don't care if you have a little printed out keyboard if you want. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 semitones. And it's generically speaking some sort of seventh, right? D, E, F, G, A, B, C. 1, 2, 3, 4, 5, 6, 7. Okay, let's do that. Generically speaking, it's what? Well, it's a seventh. We just looked at a D and a C, right? D, E, F, G, A, B, C. Seventh. But how many semitones? Well, 1, D to D sharp, 2, 3, 4, 5, 6, 7, 8, and then C flat would be 9. So 9 semitones. And it doesn't really matter what octave you look at it in. It's not going to change the count. So let's do another semitone example. Let's do a few in bass clef. Let's do A sharp and an E flat. So just looking at this, it's generically speaking, it's some sort of fifth, right? A, B, C, D, E. 1, 2, 3, 4, 5. So generically, half the answer is a fifth. How many semitones between A sharp and E flat? Well, put my key here, and it's 1, 1, 2, 3, 4, 5. 5 semitones. Okay, hopefully that is clear, and I'm not sure if I'm getting any questions, so I'll just reload. So if you're having any questions, let me know, and hopefully that is making sense. Okay, so this is, we've looked at generic intervals, we learned how to count semitones, and we're doing that for a reason. And it's because each of our intervals, what I call the specific intervals, not just the thirds, fourths, fifths, but the minor thirds, minor fourth, perfect fourths, and so on. Each one of those specific titles is dependent on semitones. So let's start with, again, the easiest one, the perfect unison. Perfect unison has 0. And I think maybe the last lesson in the unit has a chart which lists the semitones. Perfect unison has 0. Perfect octave has 12. And you can go through and count them. And what you'll find is that probably there's not going to be a lot of those on the exam, because it's just an octave and it's fairly obvious, and doesn't really reflect kind of an understanding of the complexity of the content in terms of what we're interested in seeing. But let's start with seconds. So there's 2 primary types of seconds that you'll encounter, and 1 secondary type of a second. And I'll just make a couple examples, and I'll use the same pitches for each of these, just so you can see that the generic interval isn't going to change regardless of the accidental. Yeah, let's do one more. Okay, so we've got some variety there. And though it's not necessary, I'm just going to put this natural sign here so that you can see that this is no longer flat, or no longer sharped. All right, so here's the first one. We have an F and a G. Now, generically, it's a second, right? 1, 2, F, G. How many semitones? We have 1, 2 semitones. Now, one thing I wish I had is some way to type onto this, but 2 semitones is considered a major second, and most are a whole tone, and most of what major scales are built out of and minor scales are built out of are whole tones. And if you remember from making scales, it's the semitones which were less common but sort of typified how a scale sounded. So this is a major second. Major seconds are another way of saying a whole tone. Let's look at the next one. This is also a second, generically speaking, but here, F sharp to G, there's only one semitone, the one motion. So F sharp to G is called a minor second. So when you have 2 semitones, it's a major. When you have 1 semitone, it's a minor. Okay, let's look at this one. How about here? We have an F and a G flat. Well, it is a second, right, because we have an F and a G. And there's 1 semitone. So this would also be a minor second. How about F and G sharp? Well, here is a little different, right? We have 1, 2, 3 semitones. So when we had 1 semitone, it was a minor second. When we had 2 semitones, it was a major second. When we have 3 semitones, it's called an augmented second. Now, theoretically, if we had less than 1 semitone, it would be a diminished second, but those don't really show up in nature. They don't show up in the music we're looking at much in this course. But this augmented second with 3 semitones, this shows up in the course. We see these, and if you remember where we see them in our harmonic minor scales. When we raise the 7th scale degree, the distance between the 6th and 7th scale degree becomes an augmented second. So these have 3 semitones. Okay, so we have a major second, 2 semitones, minor second, 1 semitone, minor second, 1 semitone, and an augmented second. And just so you can see this, let's do this also. How about an F and an F sharp? Wow, how about this? What's the interval here? We have, it's 1 semitone. Is it a minor second? F and F sharp? No. Actually, it's a unison because they're on the same line. Generically speaking, it's some sort of unison. Now, unisons with no semitones in between, for instance, like an F sharp and an F sharp, that would be just a perfect unison. But when a unison is with 1 semitone in between, it's called an augmented unison. And it's, again, it is not common, but it does exist. But always look at the generic interval first. That gives you so much information that's critical. Okay, so we've made these seconds. We have the minor with 1, the major with 2, and the augmented with 3. Let's invert them. So we're going to do that just by taking the bottom note and putting it above the top note. Bottom note above the top, bottom note above the top, bottom note above the top. So let's do the same thing. We have what type of interval now? Well, if you remember, when you invert seconds, they become sevenths. And remember, you can remember that easily because they add up to equal 9, correct? 2 plus 7 is 9. So these should all be some sort of seventh. But if you want to be sure, 1, G, 1, 2, 3, 4, 5, 6, 7. All right, so from G to F is 7. You can count lines and spaces. You can count letters. It doesn't matter. You can count keys on the piano. But when you're looking at generic intervals, Don't be fooled by any kind of accidental. It just doesn't matter. So we have all sorts of sevenths here. The question is what type? So let's start with this first one. We had a major second with one semitone in between. Let's see how many semitones we have now. Okay, let's start with our G, and we're going to go up to F. So we'll start on the G here, this blue key. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 10 semitones between G and F. Now, 10 semitones is considered a minor seventh. So what we had here was a major seventh with 2 semitones going to a minor seventh with 10. So our major became a minor, our second became a seventh, and if you add up the major with 2 semitones to the minor with 10, you get 12. And if you remember, between our octave, we have 12. So essentially, if we look at them together, here's our minor with 2. And then if we put the bottom top, essentially we're making an octave between these two Fs. Between the bottom and the top, we get the rest of the 10. So here's 2, and then 10 equals 12. Major becomes minor, and 2 becomes 10. So theoretically, if we went from 1 semitone in our minor second, when we invert it, we should get 11 semitones, right? Again, equaling 12. But let's start on G. 1, 2, 3. And remember, I'm doing motions away. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 semitones. So between F sharp and F sharp, we're going to have 12, right? Minor second turns into a major seventh. So our minors turn into majors. Our seconds turn into sevenths. Let's again look at this one here. We had a minor second with 1 semitone. We're going to turn into a major seventh, and it's going to have how many semitones? 11. But if you don't believe me, start with the G flat. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So F would be 11. So that's a minor second turning into a major seventh. Let's look at our complicated one. Here is our G sharp and our F. And we had an augmented second. And we still are going to have some sort of seventh now. Seconds become sevenths. But let's count the semitones. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now here we only have 9 semitones because we had 3 plus 9 is 12. So what happens to our augmented? Well, our augmented becomes diminished. So now we have a diminished seventh, and our diminished seventh has 9 semitones. So let's just, before I do another set of intervals, let's look at another graphic. And again, these graphics are all in the lessons, and I'm just going to, and I think this is kind of helpful for some of this. So here you can see the inversion of the generics, and we talked about it. For instance, our unison becomes an octave, our second becomes a seventh, third, sixth, fourth, fifth, sixth, thirds. It always equals 9. But here is also another interesting little tidbit. When we invert an augmented chord, like we just did, F and G sharp, we had an augmented second, it always becomes diminished. So in some ways, this chart is the answer for your augmenteds, right? We had an answer for your inversions. We had an augmented second, right? The augmented becomes diminished. The second becomes a seventh. Say I had a minor third. Well, my minor is going to become a major. My third is going to become a sixth. How about a perfect fifth? Well, my perfect is going to become a perfect. So perfect fifth becomes a perfect fourth. Diminished octave. Well, it's going to become an augmented unison. How about a minor sixth? Minor sixth is going to become a major third. So really, this this is kind of the standard pattern for inversion, and we'll continue and do more of them. One thing to realize is that certain intervals don't, let's see, that perfect intervals are kind of singular. Perfects either become augmented when they get bigger or diminished when they get smaller. And those are unisons, fourths, and fifths. Unisons, octaves, fourths, and fifths. But thirds, sixths, seconds, and sevenths, they're a little different. Thirds and sixths primarily, what you'll find in most scales, and we're going to essentially be testing you on intervals you find in scales, our minors will become majors and our majors will become minors. But when a minor gets smaller, it will become diminished. When a major becomes bigger, it will get augmented. Now, the only real augmented interval we see a lot of in just our regular scales, which is what we're sort of focusing on in the exam, is that augmented second, which when you flip it over would become diminished. So that's the one to primarily focus on. But if you learned these two charts, the one I showed you and this one here, that the perfect gets smaller, it becomes diminished, and it gets bigger, it becomes augmented, and then the minor becomes major, and when the major gets bigger, it becomes augmented. When the minor gets smaller, it becomes diminished. And this bottom one refers to sixths and sevenths, seconds and sevenths, and the top refers to unisons, octaves, fourths, and fifths. If you combined that with the other chart I was just showing from the book, you can really do all of your inversions. You can do almost everything you need to do for this exam. So, but let's push on, and next we're going to look at thirds and sixths. And thirds and sixths, they start primarily as major and minor. So we're going to focus on these as major and minor intervals, and not really worry about too much else. Okay, let's go back to our handy dandy little note thing, and let's just make some thirds and sixths. And I'm just going to kind of work with the pitches we already have a little bit, just for ease. Because then we have the inversions right there. And, I think I will include one of these funkier intervals. Let's see, which one? This one is kind of classic, so let's do that one. Maybe I can do that. Yeah, this will be easier to see. Okay. So let's look at the first one. So here we have an A and an F, and when we invert it, we have an F and an A, and when we invert it, we have an A and an F. What is the distance between A and F? Well, generically, it is a third. And when we invert thirds, we get sixths, right? Because it equals 9. So let's start on F here. And we're going to go up and count the motion. So 1, 2, 3, 4. So between F and A, we have 4, right? 1 semitone, 2 semitones, 3 semitones, 4 semitones. And if we invert that, we have between A and F, well, how much would it be, right? We have 4, so it's probably going to be, what, 8, right? Because it equals 12. 1 semitone, 2 semitones, 3 semitones, 4 semitones, 5, 6, 7, 8. So when we invert this interval, it goes from 4 semitones to 8 semitones. Okay. So when an interval is a third and has 4 semitones, it's called a major third. So this is our major third. And most of our major scales, the first 3 notes, The distance between the first note and the third note is going to be a major third, and it's really what makes the scale sound kind of happier. So this is our major third with 4 semitones, and when we invert it, our major becomes minor, right? So we go from a major third to a minor sixth. Now here, and remember, we have 4 and then 8. But here, with F sharp and A, we still have a third, right? But if we look at the semitones, we go 1, 2, 3, right? 1, 2, 3 semitones. So this is a minor third with only 3 semitones. And interestingly, when you switch, you go from 3 all the way up to 9 semitones, right? It's got to equal 12. So here, the major with 4 becomes minor with 8. Here, the minor with 3 becomes the major with 9. And this, I mean, for me, as a student, this was always counterintuitive. I kind of figured like the minor, sad-sounding third would invert to another minor-sounding interval. And it does. It's the same notes, but it's called major. And it's called major because it's bigger. Essentially, it's bigger than the first third we looked at, the major third that becomes a minor sixth. Well, the sixth that is inverted from a minor third is a major sixth because it's got 9 semitones instead of 8 semitones. But if we just look F sharp to A again, 1, 2, 3 semitones, and A to F sharp, 1, 2, 3, 4, 5, 6, 7, 8, 9. So minor third, 8 semitones. Major third, our major sixth, 9 semitones. Let's look at the next one. F and A flat, we have 1, 2, 3 semitones. And if we invert it from A flat to F, 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 semitones. So minor third inverts to a major sixth. Let's look at this last one, E flat and C sharp. So this looks really nasty and complicated because we have different accidentals. But remember, don't panic. The first thing you want to do is just count generic intervals. So E, F, G, A, B, C. This is a sixth. Doesn't matter anything else that's happening. It's some sort of sixth. Let's look at the number of semitones. So before, our minor sixth had 8. Our major sixth had 9. So if we have 10, it's going to be augmented. If we have 7, it's going to be diminished. Because if minor gets smaller, minor has 8. So if minor goes down to 7, it's getting smaller, it's diminishing. And if major has 9, so if it goes up to 10, it's getting bigger, it's going to become augmented. So let's see the difference between E flat and C sharp. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so it's gotten bigger. This is called an augmented sixth. And it is one of the only other augmented intervals that tends to be found. And it tends to be found within chords and more complex types of pieces, but it is common. It is a common interval. So if we have a sixth that has 10 semitones, that's an augmented sixth. And if we invert this, so let's just grab the E flat and put it above the C sharp. What do we have here? Well, we have a third, right? C to E. And if you remember, our major third had 4, our minor third had 3. So if it's 2, it's diminished. But if our major third goes to 5, it's augmented. What's it going to do? So we have C sharp to E, so 1, 2. We just have 2 semitones. So this is a diminished third. And if you remember, augmented will go to diminished. So augmented sixth. Oh, that's annoying. Diminished third. Augmented sixth, diminished third. So this is thirds and sixths. And again, that chart's important. Majors go to minors. Minors go to majors. Thirds go to sixths. Augmenteds go to diminished. And the semitones are going to equal 12. So if we had 4 semitones, it's going to invert to 8. And if we had 3, it's going to invert to 9. And if we had 2, like this here, C sharp and E flat, it's going to invert to 10 because it's going to equal 12. Because essentially what we're doing is we're creating, if we look at the outside notes here, we're creating an octave, right? So between F and F up top. So between these two pitches, when we invert an interval, essentially we're creating that. Okay, so I'm going to do the last set of intervals, the fourth and the fifth, and I'm going to talk about the tritone. And then I'm going to review the way inversions work. And again, Piazza is open if you want to type questions in. I'm happy to answer them. If you have a specific question about a homework, I'm more than happy to go over that with you. If I'm not covering things a way that is useful, you can let me know that too. And I guess I've been drolling on for quite a while at this point, which I did not realize. I'm just so into intervals. Oh my God, it's so amazing. Let's just move to fourths and fifths. Let's see. Let's do E and B. All right, that's a fifth. And fifths are generally called perfect fifths. We don't really see augmented fifths and diminished fifths too often, but this is a perfect fifth. So what happens with a perfect fifth? Well, if we count up from an E to B, 1, 2, let's say 1, 2, 3, 4, 5, 6, 7, 8. So if you have 8 semitones and it's a fifth, it's a perfect fifth. So let's do it again. 1, 2, 3, 4, 5, 6, 7. Oh, sorry, 7 and 7. Strike that. 7 semitones is a perfect fifth. Now, it is not uncommon to see, well, before we do that, let's invert our perfect fifth. Perfect inverts to perfect, so perfect fifth inverts to a perfect fourth, right? 5 and 4, that's the pair, that equals 9. So if this had 7 semitones, this is going to have 5 semitones between B and E. 1, 2, 3, 4, 5, right? Because it's going to equal 12. So that's our perfect fourth, the perfect fifth. And as long as you have those intervals, let's see here. Let's do G flat to C flat. See what we have. We have a fourth, right? G, A, B, C. If we count semitones, 1, 2, 3, 4, 5. We have 5 semitones. If I invert that, I'm going to go from a perfect fourth to a perfect fifth. And perfect fifths will have 7 semitones. So that's fourths and fifths, just like all the others following the pattern. The one exceptional kind of interval is what's called a tritone. It's called a tritone because there's 3 whole tones in it. And the one that's kind of most common is between F and B, and I say it's common because it's based on white notes, and that's always things we encounter more when we're studying this. But if we count from F to B, we have what? Well, we have a fourth. Now we know a perfect fourth has 5 semitones. How many does this have? Well, this has 1, 2, 3, 4, 5, 6 semitones. So when you have a fourth with 6 semitones, it's a perfect fourth, but 1 semitone bigger. So when a perfect fourth gets bigger, it becomes augmented. So this is an augmented fourth. And when we invert an augmented fourth, it's going to become a diminished fifth. So here's B and F again, B, C, D, E, F. This time it's a fifth. Our augmented is going to become diminished. But regardless, they both have 6 semitones, right? Because 6 and 6 is 12. And that's why it's called it's called a tritone. Because if you look from F to B, for instance, essentially there's 3 whole tones. 1, 2, 3. So tritone, 3 tones, 3 whole tones. It used to also be called the devil's interval because it's particularly dissonant. Let's look and see if we can make another augmented interval. So let's do F sharp, and let's make a diminished fifth, which is diminished fifth, augmented fourth is our tritone. Let's make a diminished fifth above F sharp. So let's start with a C sharp. Let's see what we got here. Well, it's a fifth. F sharp to C sharp. Let's see, 1, 2, 3, 4, 5, 6, 7. Wait, that's too many. This has to be 6 semitones. So not a C sharp, but a C natural, or we can just use a C note head. So here is our diminished fifth, right? So if we count up from C, F sharp to C, 1, 2, 3, 4, 5, 6. And if we invert it, C to F sharp, we have 1, 2, 3, 4, 5, 6 semitones. And then now this becomes an augmented fourth. Because remember, our perfect fourth has 5, so if it gets bigger, if it goes to 6, it becomes augmented. Our perfect fifth has 7. If it gets smaller and goes to 6, we have diminished. So these are your intervals. But again, I want to reiterate that this sort of tells you almost everything you need to know in terms of how to invert. The majors become minors, the perfects become perfects, the augmenteds become diminished, diminished becomes augmented, and the generic intervals will equal 9. If you can just remember that and kind of a few of the basic semitone combinations, the perfect interval, the perfect unison has 0 semitones, the minor second has 1, the major second has 2, the major third has 3, minor third has 3, major third has 4, perfect fourth has 5, the augmented fourth, diminished fifth, the tritone has 6, perfect fifth has 7, major 6, 8, minor 6, 8, major 6, 9, minor 7th, 10, major 7th, 11th, perfect octave. If you could just sort of memorize that sequence, we list these kind of sub-intervals because you might encounter them, but they're less rare. Really, if you can just remember unison, second, second, third, third, fourth, fourth, fifth, fifth, sixth, sixth, seventh, seventh, eighth, and just kind of write that down with the number of semitones. You can just write it down on the when you start your exam. You need to start with a blank piece of paper. I should reiterate that. But then just make yourself some notes and count and take your time. It's we'll be giving you a key signature, so they're in specific keys, these intervals, so you want to make sure you refer to the key signature. But other than that, it's pretty straightforward, and hopefully I haven't completely lost you. If you have questions, please ask. I'm happy to answer them. Bye-bye. See you next time.